Very good morning. Okay. Yes. In the last class, we started with the stick diagrams. So stick diagram is nothing but what? So by using of different color sticks, we can draw a diagram which shows the representation of the schematic and is guidelines. It provides the guidelines for the layout. So it can provide the information such a way that it can show the information. The number one is how many layers are required, what is the each layer, okay, these things. And the stick diagrams has many advantages, and also at the same time they have disadvantages. We already discussed in the last class. So disadvantages are in such a way that it cannot show so geometrical dimensions of each layer. It will not show. Okay, and moreover, the parasticks which will produce us between the two layers also missing the information. Okay, and as well as the body and wells connections also unable to show here. So these are the setbacks, but anyhow it will do better, somehow good things for the layout engineers. It provides some information regarding the layout of a circuit, so that it has very advantage, so that we will consider this. It is intermediate between the schematic and the layout. So here is the some of the colors which are dedicated to the some layers. Okay, so for metal blue, poly red, N diffusion green, P diffusion yellow. So contact cuts black, influence yellow. So that is the way we can represent so each layer with a different color. So the rules of the stick diagrams. While you are drawing the stick diagram, we have a 4 rules, of course, the basic rules. The first rule is nothing but whenever two same type of metals or same type of layers, okay, same type of layers are crossing each other or touching each other, then there is by default electrical connection is there. No need to put anything to make the connection. So second thing is, whenever you have a different layers cross each other or touch each other, so by default there will not any electrical contact. So that if you want electrical contact, then put contact cut. So like this. See here I am showing it as. So this one is the that one. There is no electrical contact here and here, but if you want to make the electrical contact, put here contact cut here and here, then this is the right figure. This is only for the different layers. And third one is for making a transistor. Definitely we need the two different layers. One is the polysilicon, one more is the diffusion. But here, no need of any contact cut to make the electrical contact. Transistor can be represented with a crossing of polysilicon with the diffusion. So either N or P diffusion. If you try to put contact cut, okay, so wherever they touch each other, so it is not the transistor. So this is the wrong. This is only the right. And one more is, last rule is, whenever you are going with the CMOS technology, first you should make the demarcation line which can separate the PMOS and NMOS devices. Generally, above the demarcation line, we can place all the PMOS transistors, and below the demarcation line, we can place all the NMOS devices. So in the CMOS technology, since we already know that we already studied that, so we have to keep both NMOS and PMOS transistors with equal number. Okay, so so that to avoid the confusion, so demarcation line is required that will separate the PMOS and NMOS devices. Yeah, here is a one animation diagram that will show how the transistor can be made with the layers. So this is the transistor I want to make this. Okay, this is the N diffusion. So now polysilicon is required to cross over this. Then this is called the transistor. This is the poly. This entire thing is transistor. Transistor. Yeah. So now, whenever it is poly is acting as a gate, this side becomes the source. This side becomes the drain. Yes, this is the transistor. So the next one is, as we are going to discuss about the stick diagrams, as I told, the stick diagram is intermediate diagram between the schematic and the what? Layout. This is the schematic. This is the layout. So in between, we need the stick diagram. This is the stick diagram. Yes, this is the stick diagram of the CMOS converter. Okay. So now we'll start with the how to draw the stick diagram. Remember the colors. Okay. So one of the finest thing is remember the colors. Okay. Then we can start with the new slide. So I'm opening one white screen. Yeah. Here I can draw. So first of all, take the inverter. Everybody know about inverter. So we know. So inverter or not gate. Inverter or not gate. So not operation. So inverter. So I think you know about this not gate is nothing but this is the symbol of the not gate or the inverter, which produces the inverse of the input. Suppose input may be A, output may be out. So V out you can say. If you want to put in the logic, you can say Y is the output. No problem. So generally we have three different technologies. One is the NMOS technology. One is the PMOS technology. One was the CMOS technology. Take up to here. First, you have to draw the schematic diagram in all the cases. Yeah. For the NMOS inverter is, this is my NMOS inverter. So depletion MOSFET sits on the head of the enhancement MOS transistor. So like this. This is the enhancement transistor. Source is grounded. Here you can apply the A as the input. And this is the depletion MOSFET. This is the VDD. In the NMOS technology, drain is connected to the VDD. And gate and this is the gate is connected to the source of the depletion. So this is the source. Yeah, wait. I will change the color. This is the source of depletion. This is the source of the enhancement. You can take the output here. So you can say Y, no problem. So for this, we need to draw the stick diagram. Stick diagram. So I don't know who are in the meeting. So nearly 10 members are in the meeting. So please respond whenever I am calling. So I may not be called with the roll number or name. So when I ask, anybody can voluntarily can respond. Okay, first, Subramaniam. Yeah. See, I'm talking about the NMOS. This is my NMOS inverter. What is this diagram name? Schematic. Schematic. Schematic diagram. Okay. This is the symbolic diagram. Symbolic diagram. Symbolic diagram is same for all the technologies. Schematic is different. Schematic is this one. Now, Subramaniam.
Yes, sir.
So we need to draw the stick diagram for this fellow. So I want to know, I want to write everything without any confusion. I want to put the notation of everything. This is the source. This is the drain. This is the source. This is the drain. Okay. This is the M1. This is the M1 transistor. Let us say this is the M2 transistor. Okay. Now, first we'll start with the metals. VDD and ground are the two supply rails. VDD and ground are the two supply rails. So supply rails are represented with the what? Blue color. Subramaniam.
Sir, metal.
Right?
Yes, sir.
Yes, metals. VDD and the ground are the metals. They can metal one. They can represent with the blue lines. So
Yes,
I will take 1 minute. I will take highlighter. Yeah, good. Okay, color change. Yes, where it is. Yes. So this is my VDD. This is my ground. Understand?
Yes, sir.
This is one layer. This is one more layer. Both are the same materials. Metal one layer. Okay. So now, since both are the what type of transistors they are? NMOS transistors. So that we need the N diffusion layer. N
Green
diffusion
color.
layer color. Yes, color is what? Green.
Green.
Yes. So I can take one N diffusion layer. So like this. Yes, this is my one N diffusion layer. Got the point?
Yes, sir.
Yes. Now, so for the first M1 transistor, one gate is required. Gate is nothing but polysilicon. The polysilicon color is what?
Red color.
Yeah, this is my gate. One polysilicon. So first I will make the notations. Then I will go for the other things. I will take the pen and change the color. Okay, wait. Yes, I will take this color. This is the VDD. This is the VDD. This is what? Ground, G and D. Okay. This
Yes.
is the, yeah, for the gate you are applying the supply A or logic A is given to the gate of the M1 transistor. So A it is. So whenever it is a P diffusion, so it is crossing over the polysilicon is crossing over that. This becomes the gate. Okay, and this becomes the source, and this becomes the drain. See, as you look into the schematic, the source is connected to the ground. Yes, am I correct or not?
Yes,
the
sir.
source is connected to the ground, but the diffusion layer, N diffusion layer, and metal layer, both are two different materials. To join them, one contact cut is required. Am I correct? The color of the contact cut is what? Black. So that I will put a black color contact. I will make this 1 minute. Wait. Yes. So this is my black color. So here is a one contact. Got my point?
Yes, sir.
Similarly, so on the top there is a VDD. Okay, one metal is there, one layer is there, metal layer is there, and another one is N diffusion. Both are joined so that because these two are dissimilar layers, you need to put the contact card here also. Okay, then the electrical contact is established. Okay, the second thing is yeah, the second thing is second transistor. M2 transistor, already N diffusion layer is there. We need to run polysilicon over that. This is my polysilicon. This is my polysilicon. And polysilicon is C. Here is M1 transistor C. The gate is again joined to the source. So that take like this. This is. Understand?
Yes, sir.
Yes. Now, of course, this is the depletion MOSFET. So to show the difference between the depletion and enhancement MOSFET, one implant is required with the yellow color. So I will take the yellow color. This is my implant. This implant shows this is the depletion MOSFET. It shows this is depletion MOSFET. This is the implant. Clear?
Yes, sir. Clear.
Yes. Now one more thing is we need to give the representation. So for the M2 transistor, the above one is the drain, the bottom one is the source. Yes. So as per the circuit, the source of M2 and drain of the M1 is joined here automatically because both are same material. Okay, need not to put anything. Okay. So and one more thing is this is the output Y. Okay. So source is connected to the source of M1 is connected to the ground, and the drain of the M2 is connected to the VDD. And one more thing here you can say buried contact you can show. So buried contact can be represented with the C. I will show the color buried contact C. Buried contact you can represent with the, yes, this is the buried contact. So I hope you understand. This is the buried contact. We can put the buried contact for the implants. Okay, so that here I want to show the this 1 minute. Where is my this one? already consider. Okay, anyhow, we want to draw once again. Instances when okay. Okay, so I will make it fast. First, you need to run. Yes, this is one VDD ground
Ground.
and N diffusion green. N diffusion. Okay, and contact cuts are black to make the actual contact between this and here. And one more is polysilicon is required, which is red color. Okay, there is one polysilicon. There is one polysilicon. You can run like this. This one more transistor. And now, what is that one? Implant. This is the implant to show the what? Depletion
Depletion
MOSFET. And one more is buried one which. Okay. Number of times separation is the contact cuts. Next polysilicon, red color. This is one poly. Here is one more poly. Okay. So now implant yellow, a small yellow rectangle box which should be provided, and inside that there is a buried contact that we can show with the like this with dimension like this. Yes. Okay. Now notations. Notations. Color changed. Yes, I will take this color. Yes. Now, so VDD ground. This is the A. This is the output Y. This is the source, drain,
Gate.
gate. This is the drain. This is the source, and this is the gate. Yeah, this is the so NMOS inverter stick diagram.
Yes.
NMOS inverter stick diagram. Similarly, for the PMOS, everything is same except in place of N diffusion, there is a P diffusion. So everything is same. So I'm going to draw the same thing once again. This is my VDD. This is my VDD. And this is my ground. Okay. And now I will take the P diffusion. What is the color of P diffusion?
Brown.
Yellow. This is my P diffusion. My P diffusion. Okay. Okay. So then make the contact, lateral contact between the what metals and P diffusion. So then again go to the polysilicon. This is my polysilicon, and this is my one more polysilicon. Yeah, here is the. Yes. So this gate is connected to the drain source and the yellow connection. Yes. So clear. So now show the implant region. This is my implant region. Okay. And there is my buried contact is required. So that take the color and apply the buried. Yeah, this is my buried. Okay. So now we can put the what is it one? Notations. Yes. So take the pen and taking the pen and write the so notations. This is the VDD. This is the ground, and this is the A. So this is the what? Source. This is the drain. Okay. Clear. Gate and source is connected. Gate and source is connected. Here is the. This is the source, and this is the drain. And you can take the output is here. Output is taken here. You can take any metal, or you can extract the any metal. You can better take the metal. Metal. 1 minute. This metal. This is the output line. So output line. So we need the contact, every contact between the metal and so P diffusion. And one more thing is CMOS. You know about the CMOS. The CMOS inverter circuit is different. As we know, the CMOS inverter circuit is this one. CMOS inverter. So one PMOS and one NMOS should be there in the circuit. Yeah, this is both should be are equal in number. VDD. So this is the PMOS transistor. This is the NMOS transistor. Both the gates are joined together and give the input A, and output is connected here by. Here the notations. So M1 transistor. M1 transistor. So this is the M1 transistor. This is the M2 transistor. Okay. In the M1 transistor, source is grounded and drain is here output. In the PMOS transistor, the source is VDD and drain is output. Yeah, this is the schematic. For this, we need to draw the what is that one? Stick diagram. For that, before going to the what is that one? So inverter diagram. First, you should with what you will start? You will start with the demarcation line, which separate the PMOS and NMOS devices. This is my demarcation line. Yes. Keep so in mind that all the PMOS should be above, or all the NMOS should be bottom. Or you can say different also, no problem. This is my demarcation line. Now I will start my sketching. That means I will take the metal layers. So one is the VDD line, one more is the ground line. Clear? So for making NMOS transistor, I need one depletion layer with the color of N diffusion layer with the color of what? So green. Yes, like this green. This is my N diffusion layer. Okay. And similarly, for the PMOS transistor, we need the P diffusion, which is colorized. So yellow. This is my P diffusion. I hope you understand. So now I need polysilicon to make the transistor for both. Gate is the polysilicon, so that I will take the red color polysilicon. So I can. This is my gate for this. This is my gate for this. See, in the schematic, our two gates are joined together, so that I will join these two lines, and I will apply the input lines. Okay.
Yes, sir.
So if you want to give the notation, then it will be better at this point, so that I will do the full notations. Thereby you can understand. So this is my source. This is my drain of NMOS. This is my source, and this is drain of the PMOS. From the circuit, you can understand both the drains are joined together. Both the drains are joined together. So that to join both the drains, don't extend these two lines, because these two are two different layers. So that take a metal with blue color. Take the metal with blue color. Okay, then we can put them so like this. Yes. So this is my metal. Use it to join these two things. Okay, and output I can take here, so that I can extend the metal. I can take the output here. Input is here. Okay, and one more thing is I want to put the contact cuts. So wherever the contact cuts are required, I can put here. So here is a ground and source joint contact cut. Here source and VDD joint contact cut is required, as well as drain and this metal is for P diffusion and metal need to join. So metal contact is required. And so N diffusion and metal is joined here, so that one contact cut is metal contact is required. I think it's finished. Nothing is there because both are the arrangement transistors. No need to put any implants.
Yes.
This is the how simple it is. See, this is the ground. This is the VDD. This is the easy the stick diagram. You can draw it. Advainandi? So NMOS, PMOS, NMOS, and CMOS. CMOS. So any doubt, please respond.
ఇన్పుట్స్ అవుట్పుట్స్ తీసుకోవడానికి కూడా మెటల్ కాంటాక్ట్స్ పెట్టాలా?
ఎక్కడ పెట్టలేదు మనం ఇక్కడ
అంటే
చూడండి.
వై అవుట్పుట్ తీసినప్పుడు బ్లూ లైన్
ఎందుకు తీసుకున్నాము ఇక్కడ? ఫస్ట్ దాంట్లో తీసుకోలేదు చూడండి. తీసుకోలేదు. ఎన్ డిఫ్యూజన్ NMOS ఇన్వర్టర్ తీసుకోలేదు. ఓకే, సో PMOS ఎందుకు తీసుకున్నాం అంటే PMOS లో గేట్ సోర్స్ తో కనెక్ట్ చేస్తున్నాం. సో యూ కెనాట్ టేక్ ద అవుట్పుట్ హియర్.
ఓకే,
క్లియర్. సో అందుకని ఇక్కడ ఏం చేసామంటే దిస్ ద పీ డిఫ్యూజన్ కాబట్టి దీన్ని ఎక్స్టెండ్ చేసి మెటల్ తీసుకున్నాను. ఇక్కడ ఏం చేశాను, దిస్ ద టూ డ్రైన్స్ ఆర్ జాయింట్. సో ఈ డ్రైన్ ని జాయిన్ చేయాలంటే రెండు సేమ్ మెటల్స్ కాదు కదా. One is P diffusion, one more is N diffusion. So definitely you can take the metal to join them and extend the metal to collect the output.
yes sir, understand.
Students who are in the meeting, do you have any doubts? Have any doubt? Nandan, Sankalp?
Understood, sir.
Yeah, Avinash, Hemant, Karthik. If it's okay, I will move. Okay, good. So the next one is, I will take one more thing. One more. What is that one? Yes. Do you want? You can take this snapshot. Okay, this one,
Yes sir, please.
So one more way. So here is, I am going to show one thing. Very simple to draw the schematic diagram first of all. Then stick diagram is easy. First I will start with the NMOS logic. Okay. So see, NAND gate I want to implement. I want to draw the NAND. Okay. NAND gate. I want to implement I want to draw the stick diagram of NMOS NAND gate. So NAND gate, how it is look like? So this is the NAND gate, 2 input NAND gate only I can take. So A is one input, B is one more input, and Y is output. What is the Y? Y is equal to A dot B whole bar. Am I correct?
Yes.
I want to draw the stick diagram for this using NMOS technology. First draw the schematic, NMOS schematic for this logic. Okay, so see, whenever you have a dot product, dot means in NMOS dot means series. So plus means in PMOS అయితే dot ఉంటే PMOS లో అయితే సిరీస్ వస్తుంది, ప్యారలల్ వస్తుంది, ప్యారలల్. ఓకే, ఇక్కడ ఏముంది, ఏకి బికి మధ్యన డాటే ఉంది కదా. డాట్ ఉంది కాబట్టి 2 ఇన్పుట్స్ కాబట్టి 2 ట్రాన్సిస్టర్స్ కావాలి పుల్ డౌన్ లో. ఆ రెండు ట్రాన్సిస్టర్స్ ఎలా ఉండాలి, సిరీస్ లో ఉండాలి. ఓకే, దిస్ ఇస్ మై వన్ ట్రాన్సిస్టర్ which represents the A input, one more transistor which represents the B input, and one load is required, that is default. This is my load. So load is always depletion in the enhancement, so NMOS logic, and whose gate and source is joined together. This is the output Y. So this is one enhancement MOS transistor, this one more. So this input is A, this input is B. This is the VDD, and this is the ground. This is the ground, G and D. Yeah, this is the source of M1. This is the source of, so MA you can say, otherwise this is the MB. This is the ML, load, ML. Okay, so that you can give the notation. source, I will change the color. Okay, this is source of MA, this is the drain of MA, this is source of MB, drain of MB. Okay, so and one more thing, this is the source of MN, this is drain of MN. This is. Got my point? Students, understand this one? So why these two are series or parallel? These two transistors are series or parallel?
Series.
Hello, series lo unnaya, parallel lo unnaya?
Series lo unnaya.
Series lo unnaya. Why? Why already given here. Dot means series in NMOS transistor, NMOS technology. Any suppose if 3 input అనుకోండి, 3 input NAND gate అనుకోండి, A dot B dot C వస్తుంది. అప్పుడు 3 transistors మన series లో కనెక్ట్ చేయాలి. So okay, anyhow, step diagram for this one is very easy. So I will go with this. Take the highlighter. So take the colors. Blue. I will start with the blue. This is mine. What this for? This for letter. VDD account metals. Okay. All are NMOS transistors. Am I correct? All are NMOS transistors. So that one single N diffusion layer I can take. So this is my N diffusion layer. 1 minute. This is my N diffusion layer. Yes. So I want to join. So this N diffusion layer with this metal and with this N diffusion layer with this metal. This may be the VDD. This may be the ground GND. Okay. So now I want to make the polysilicon for the A transistor and B transistor. So that I need two. Yes. This is 2. This may be the A and this may be the B. Okay. So and one more thing is, one more load transistor is required. That is, one polysilicon can run like this and whose gate and source is joined together. Yes. Of course, the load transistor is what type of load transistor it is? Depletion. So that we need the implant region. This is my implant region. And moreover, buried contact is required. So that buried contact I can represent with this. So diamond symbol. Yes, this is my buried contact. Now I can show the notations of each. So whether they are correctly joined or not. So all the connections. Yes, I will start with this one. This is the source of MA. This is the drain of MA. This is the source of MB. This is the drain of MB. So this is the source of ML load. This is the drain of ML load. This is my output Y. Students, do you have any doubt now? Very simple. So if you give all the notations in the schematic, then very easy whether they are contacted or not, connected or not. This is what? NMOS NAND gate. NMOS NAND gate. Similarly, suppose if you want to go with the CMOS technology. So I am skipping the PMOS technology that you can do at home. So I am going to CMOS technology. So let us 1 minute wait. I will draw the CMOS NAND gate circuit. Yes, I will take the yes. Okay. CMOS. What is the logic here? What is the logic here? Y is equal to A dot B whole bar. Okay. So in the CMOS, both NMOS and PMOS devices are there in equal number. Clear?
Yes, sir.
So first I will start with the NMOS devices. So since it is a dot product, NMOS devices should be connected in the series. So this is A. This is one more transistor. Yes. 2 transistors. You can say A and B. You can take like this. Whose source, ground, source, drain. Okay. Now it is a turn to come to the PMOS devices. Since there is a dot product, the PMOS devices should be parallel. So take the 2 PMOS devices because both must be equal in number. Yeah, like this. 2 PMOS devices, both are connected in the parallel. Am I correct?
Yes, sir.
Yeah. This is one PMOS. This is one more PMOS. This may be A, you can join to this one A, or you can be without joining, you can write A, B also, no problem, or you can join this here. So this is the source, this is the source. Okay. Now this is the, you can take the output here. Why? This is the ground, this is the VDD. So for this is the drain, this is the drain, this is the source, this is the source. I hope you understand. This is the way of, yes. So this is the, you can join, otherwise this A and this A can be joined, this B and this B can be joined. For this CMOS logic, the technology. So this is a NAND gate representation. How many transistors are there? 4. How many PMOS and how many NMOS? 2 to each. So PMOS is connected parallel and CMOS is connected series because of, as our, you know the rules. Whenever you have a logic equation, Boolean expression, in this dot means series for the NMOS, so parallel for the PMOS. Okay. Now can we go for stick diagram?
Yes.
Students. So at least only Subramaniam is responding. Nobody is responding. At least respond. Students.
Yes, sir.
Yeah. So is it okay? Understand?
Understood, sir.
Yeah. So now stick diagram for the this CMOS NAND gate. So this is what? This is what? And middle we need the demarcation line. First, don't forget that. First, start with the demarcation line. This is my demarcation line. So above is what? VDD. This is VDD. This metal is
Ground.
G and D. Okay. Now start with the PMOS devices or NMOS devices. So bottom I need to put 2 NMOS devices. So that see NMOS means green. This is my NMOS N diffusion layer. This is my N diffusion layer. Okay. So for this N diffusion layer, so I need 2 polysilicons to make the 2 gates. This is one gate. This is one more gate. Okay. So now put the notations and contact cuts. So I need to give the contact cut here. This is my contact kit. So for the making of electrical contact between the N diffusion or source and the ground. Source and the ground. So now, so please give the notation better at this time. You need not to get any confusion. So that I am writing here. So this is the source. This is the drain of first transistor A, and this is the source, and this is the drain of the second transistor B. Got my point? Source and drain. So from bottom, if you see the bottom, the source of the A transistor is grounded. Yes, already there. And the drain of the first transistor and source of second transistor joined together. Yes, already connection is there. Clear?
Yes,
And
sir.
now come to the PMOS diffusion. PMOS technology, PMOS devices. Then go to the above. So again, take this, what is that one? PMOS. For the PMOS, what is required? So
Yellow.
Yellow is the P diffusion layer. Yellow is the P diffusion layer. So that I will take the yellow. So this is one P diffusion. Okay, this is one P diffusion. This is one more P diffusion. There. So as per the circuit, I need 2 gates. Okay, I will take the polysilicon. This is one polysilicon. This is one more polysilicon. One more polysilicon. Okay, so now give the notations. Notations are now, it is very important. So pen I will take. I will write here with the color, some other color. Okay. Yeah. So this is take one transistor A. This is so that this is the drain. This is the source. For this B transistor, this is the drain, and this is the source. So here see this point. Both the drains are joined together. So both the drains are for P-type material. So that I will take only P-type material to join them. So P diffusion layer I can take. I can extend the P diffusion like this. I join this one. Understand? Now from the circuit, this part and drain of this B joined. So that take the metal take the metal, blue color, you can join them. See, this is, I am joining these two. Yes. So, to establish the actual contact cuts are required here and here. And similarly, output is also connected from there. So I can extend my, what is that one? So metal, and I can take the output by here. And one more thing, see here, both the sources are joined together and connected to the VDD. So sources are, I will take yellow again once again. I can join these two. I can join these two. And I can join to this one. And the sources are connected to the VDD. To make the actual contact, we need the contact cut that I am. Now, so I think you can join both A transistors, A, so that I will take this one. Don't worry. So this is the yes, this is A transistor. So both the transistors you can join. So like this, yes, this is the A, and these two join, and take the B. Got my point, students?
Yes, sir.
So I think you can draw in different way also, no problem. Okay. So A transistor, B transistor. Okay. This is the one bottom of the two NMOS transistor. Above is the two PMOS transistors. So any doubts, please, students?
No, sir.
Understood.
Yes. Sorry. What is this?
Yes, sir, please.
Any doubts, please look at once. If any doubt, please ask me. No doubt అనుకుంటే So we'll move to the next one. Next logic. NOR gate. Students, are you okay?
Yes, sir, it is okay.
Okay. Then we'll go for one more. Yes. Now, NOR gate. No, NOR gate. So NOR gate. What is symbol of NOR gate? This is the symbol of NOR gate. Am I correct? So A, B. You can increase the inputs. So Y. Y is equal to what? A plus B whole bar. Now it is plus. Plus means what? In NMOS, parallel. In PMOS, series. Understand? Hello,
Yes,
understand or
sir.
not?
Yes, sir.
Yes, now, so you can take, this is the NMOS technology I'm talking about, NMOS technology. In NMOS technology, one NMOS load, of course, depletion load, so gate is joined together like this. This is the output Y. And so because of two input, so 1 minute, small option. Otherwise, no problem. So this is the, yeah, I can take one more. Here is one more device. Yes. This is the A transistor. This is the B transistor. Yes, this is. So now take the representation. So this is the source. This is the source of A and B. This is the source of the load. And one more thing is, this is the VDD. So this is the M1. You can say MA or M1, MA. So MB, ML, load. Got my point? So here, so NMOS devices are in what? Parallel. Okay.
Yes, sir.
ఇదేంటిది ఏ ట్రాన్సిస్టర్ ఇది డిప్లీషన్ ట్రాన్సిస్టర్. సో NMOS depletion transistor. So gate is always connected to the source. Okay. So now stick diagram. Yeah, guide me. So Subramanian, guide me first. What should I do?
End diffusion.
First,
Metal contact.
start with. So VDD and
Ground.
So because it is NMOS technology, all are NMOS transistors. So that take so
Green.
N diffusion layer, color is green. This is one diffusion layer, one N diffusion layer. Yeah, you can take like this. This is one, and this is one more. Two transistors over there. This is one more. Now, polysilicon is required for the gate. This is the gate of one transistor. This is the gate of another transistor. And this is the so gate of the depletion MOSFET. You can expand this like this. This is the Y, this is the A, and this is the B. Now, I think we need to give the what is it?
Contact.
Electrical contacts for the metal and diffusion and metal and diffusion, metal and diffusion. Okay. So now, so notations are first we need to put here. So first we'll go with the notations.
The buried implant.
One minute, I'm coming to the point. So I want to not confuse you. Okay, now this is the source of MA, this is the drain of MA. This is the source of MB, drain of MB. This is the source of ML, drain of ML. Drain is connected to the ground, first one, power. And source is connected to the drain. This is the drain of MA, this is the drain of MB. This is the source of what? ML. This source, see here, drains and source are joined together. Yes, exactly. The source bottom, source of A and source of B join with the ground. Yes, exactly. Now, the above one is the depletion MOSFET, so that we need to give the implants and everything, so that implant can be represented with the what? Yellow color. So take a box, yellow color box. This is the implant, and buried contact is required. You can take with this. I can represent the buried contact in diamond symbol like this. Yes. Got my point?
Yes.
Any doubt, please?
No, sir.
Yes. Now, CMOS, we'll go for the CMOS. So, one of the thing is CMOS, more transistors are required, but it can provide the good logic levels. It can provide the good logic levels. So, anyhow, I will start with the CMOS. So, don't forget about this one. This is very important. So, while you are going to the CMOS logic, then NMOS are parallel. Yes, here is one NMOS. This is one NMOS transistor. This is one more NMOS transistor. Both are joined together and grounded. This is A and this is B. Is correct. So these things can be joined. This is the story below. And above PMOS transistors. PMOS for plus PMOS is series. So this is one PMOS transistor. This one more PMOS transistor. So this is the story. This one PMOS. This one more PMOS. This is the VDD. You can take the output is Y here. So this is the source. This is the source. This is the source. This is the source. Okay. PMOS is inside, NMOS is outside. Now do the notations. Source drain of A transistor, source and drain of the B transistor, source and what is it one? Drain of the, of course, A transistor, and source and drain of the B transistor. B transistor. You can, if you want, you can join this, no problem. You can join like this, but need not. So this will give the ambiguity. It creates some confusion, so that I am avoiding that. Okay, students.
Yes, sir.
Yes. So I can erase. Otherwise, remember that. So forget about the green lines. Okay. So this is the thing. Okay. So now go to the first demarcation line. I will start with demarcation line. Okay. Next, what? Metals. So two metals are required. Blue line metals are required. One is VDD. One more is the ground. So VDD and ground. Understand? First, start with the bottom. So two NMOS transistors. Okay, two NMOS transistors. They must be connected in parallel. So that when diffusion means this one. This is the two NMOS transistors. This is one more. This is one more. There, two N diffusion layers. We can join them. So now, two polysilicon's for the making of the two transistors, transistor A and a transistor B. Now, so metal contacts are required to make the electrical contact between this N diffusion and the metal, this N diffusion and the metal. Now write the notation for clarity. So take the pen and write the notations. So I'm going to give the notations here. This is the source of A transistor. This is the drain of the A transistor. This is the source of A B transistor, drain of the B transistor. So from this you can see both A and B transistors sources are grounded. Yes, exactly. And drains are, both the drains are joined together. Yes, joined together. Here also. Now come to the point. So PMOS logic, PMOS devices. If you go to the top, so then you can take the PMOS devices. Okay, we can start with the P diffusion. What is the P diffusion? Color. P diffusion color is what? Yellow. Take the yellow. This is my P diffusion. I need to do two transistors so that two, what is it one? So polysilicons are required. This is one polysilicon, this is one more polysilicon. Okay, so now take that, give the notations or give the contact cut. So to make the actual contact between the P diffusion and the what? Supply VDD. Now, so give the notations. Take the pen and give the notations. So I will take, okay, here is. So look at this. This is the source of A transistor. This is the drain of the A transistor. This is the source of the B transistor and drain of the B transistor. Okay. Source is the A transistor to the VDD and drain of the B transistor and drains of the AB of the NMOS are joined together. But both are different. So that I will take the again metal to join them. So that I will take once again blue. So to join these two. This is the yes. And we can extend this to correct the output Y. So now I think we need a electrical connection between this N diffusion and the metal, this P diffusion and the metal. So otherwise,
Yes, sir.
now if you want, you can join A and B. So A both A's and both the B's. Suppose this is the A, both are A. Yeah, you can join these two and you can give the A like this, no problem. Okay, and you can join these two. This is the B, no problem. This one input, this one more. This is what? This is what? CMOS NOR gate. Stick diagram. I hope you understand everything. Very simple. First, for the Boolean expression, you need to draw the schematic from that. So in the schematic, please mention each and every terminal. Okay. So then you can go for the stick. Then it becomes very easy. I hope time is now 10:55. I can stop here. So now it's your time. If you have any doubts, please. Please enter. Doubts enter. So please ask me. Say yes or no. If yes,
No,
say
sir.
yes.
No doubt.
No? No. Okay, I hope you understand everything well. Then I can
Yes, sir.
come to the conclusion that you are understanding very well. So don't confuse whatever the big equation. Okay. So first equation. So what is asking first of all? Look into that one. whether it's asking CMOS or PMOS or NMOS technology. Okay. So whatever the technology, first based on the logic. Okay, PMOS technology means only PMOS devices are there, only one node is there, one node transistor is there. In the NMOS, also only one node transistor is there. In the CMOS, there is equal number of node transistors. That's why PMOS and NMOS transistors are equal in number. Okay, and confirm about the what is the operator between the inputs. Here, if you take the NOR gate, so A and B are the operators, sorry, operands. So in between these two operands, plus is the operator. Okay, when plus is there, if you go with the NMOS, the two transistors should be in parallel. If you go with the PMOS, the two transistors should be connected in the series. Suppose if you find the dot, reverse it vice versa. Very simple. So that is the way you can, suppose if there is a big logic equation, y is equal to AB plus CD, 1 bar. Yeah, same thing you can do it. AB plus CD, 1 bar. So I think first AB, second CD. In between AB, what is there? Dot is there. So in NMOS, dot means series. Do it. Again, CD is two more inputs. Again, they can draw in the series. So between the AB and CD, there is a plus. Plus means NMOS parallel. So that these two transistors are connected in the series. AB is connected in the series, and CD is connected in the series, and both are connected in parallel. Similarly, PMOS. So the demarcation line above. So all the devices, 4 devices should be connected in first what? Parallel, then parallel, both will be series. Okay?
Yes.
Yeah. Okay, I'm going to stop here. Already without knowing that somebody has skipped. Time they are leaving the meeting. So they are not waiting. Okay, anyhow.